Howdy YouTube, Unky Joe here, Unky Joe's Playhouse. Today we're going to fiddle with that IBM server. Again, I got some more parts that came in I want to put in there and take you along for the ride and show you what we've done, the progress we've made with this server. So I don't need to sit here and babble on all day. Let's get the video started. Alright, so first things first, let me get a microphone on here. Put that on the server. We have a little server work to do tonight. A couple of things. One, this hopefully you can see it. Yeah, hopefully we got enough light down here. You can see this power supply. This is the one that is bad. So I'm going to go ahead and well, I should have turned this server the other way. Bear with me, folks. Okay. Hopefully y'all can still see what I'm doing. I'm going to pull this power supply because it is defective. Now, well, it's not defective. It's running, but it's an AC Bell, power supply. And the problem is the fan won't shut off. So this would be a nice little project for us to maybe crack into if we can figure out how to get it open and see if we can't fix it. But in the meantime, the nice folks over at Garland were kind enough to send me another power supply. So I think this is a power supply. Yeah, it's from Garland Computers. So see, it's a joy having nails. I split that box open with my damn nail. All right. Uh-oh. Well, maybe it is the right power supply. Find out here in a second. You know, I hate peanuts, packing peanuts, but that's not your problem. So let's see what they said. Now the other power supply in here is an actual. Let's see who's the manufacturer on this. That's Emerson power supply. The other one, the one that's working. There we go. So let's see. Damn. I want to get this off in one piece, but I guess it's not going to happen. So this power supply is another Emerson. Let's see. It is a It puts out 12 volt 55 amp max, 3.3 volt 2/10 of an amp. It is it doesn't say. It's the same one that's in there. Let's see. It doesn't say what the wattage is. Interesting. Not to exceed 675 watts. So, here it is, right here. So we'll go ahead, all you got to do is slide it in till it clicks, and we're golden. Now the next thing I need to do, I don't know that I'll ever use this, but I went ahead and bought an optional daughter card to put on here to give me 2 more network ports to try some stuff I'm going to be experimenting on in the future. So it's a Broadcom daughter board right there, so you can see it. So we'll put that over in the desk while we open this up. So I don't remember where that daughter board goes. Let's see here. Oh, I know where it goes now. So I need to lift this riser out. Go ahead and get you zoomed in on that so you can see me doing it. So we'll pop this riser out. This has my Mellanox card in it as well, the 10 gig Mellanox card. And then there's a blank in here. We need to push that out. There we go. You know, I don't know why I got this card. I honestly never used all 4 NIC ports on my Dell, but I just like having the option of having it. So let's get you a look-see down on the server where it's going to go. It's going to connect on right here. But eventually I'll be doing some projects that require more than one NIC. I want to try some experiments. So it's got to go, let's see here. So it must slide in here like that. And then it says press to install. Oh, that was fairly easy. It doesn't feel like it's in there quite as well as it should be, but it just snapped right in. And it looks good on the back. You can see the ports. Make sure it's not gonna pop out of there. No, it's in there firm. Okay, so now I can put my riser card back in, button this thing back up, and then we'll fire it up and see if we get any errors or anything on the screen. Alright, I've already upgraded the RAM in it. I'm not going to put any more RAM in it. It's got 50 gig of RAM, and that's plenty for the project that I plan to do on it. I do need to get some larger storage in here, but I have iSCSI storage set up, so worst case, we'll be good to go. Alright, I'm going to go ahead and button this up, and then I'll come back and we'll power it on and see what happens. Alright, so we got both power supplies in now. The new network card is in. I'm going to reach across here, so don't mind me. And I just want to plug in a monitor, so I want to see if this thing's going to fire up without any errors. Alright, moment of truth. Hang loose. I guess that's a good sound. It's not too loud. It's definitely moving some air, and I see it. It is booting. Hopefully it'll boot into Windows. Now it may make me install a driver and restart, but we shall see. Because remember, I'm running Windows Server 2016 on here. I'll turn out this big light for a minute. How's that? Oh yeah, much better. Wow. This is the normal light in my room, in my office at night. So I just think it helps to see the monitor better. I haven't had this server turned on in 3 or 4 days. I haven't been using it, so there we go. Now it's finally doing it. Just seems it took longer than normal to boot up. There it goes. I guess it has to, anytime you put new hardware in, I'm assuming it has to go through some sort of reconfiguration that requires this long extended boot time. And I'm just looking to see if there's any white smoke coming out or any smells it shouldn't be, or any lights. I've got green on both power supplies like I did before. I can't tell if the second power supply fan is running too fast but when I plugged it in initially, it didn't make the same noise it was making before, so it should come up to the SAS serial ATA controller and detect the hard drives in it here in a minute. Alright, yeah, it's going. This is the second boot screen you go through. See what I'm saying? It takes forever to boot these IBMs. I don't understand why. That's why I don't like to reboot them if I don't have to. Okay, that boot failure is normal. Now it should go ahead and bring up the SAS serial ATA controller and detect the onboard hard drives. And then it should boot. Yeah, here comes the Mega RAID 2 virtual drives, that's good. I haven't lost any of my setup. You can see we're coming up on the 5-minute and 20-second mark, so it's taking a while to reboot. Or to boot. Now hopefully it'll start going into Windows here. And then I'll be able to remote desktop into Windows. Yeah, there it goes. So that's good. It's always nice when it boots like it should. Alright, well, so we've got some progress. So let's move over to the the remote desktop, because there's not really anything more to see here. You saw me put the components in, and it looks like Windows is going to boot. So we'll stop this video here, and then we'll come back when we're actually up at the desktop. Alright, so we're up to the desktop, so that was a success. So let's see if we have our 2 new network cards in there. Well, actually, all I have to do is click here. And let's see if I see, yep, I see 2 more. So I need to name those properly. I'm going to name them GB3 and GB4, but I'm going to disable them right now. I don't need them. And there's my 10 gig Mellanox. I've got that disabled as well. Now the other thing I want to see is does Microsoft, or does the server see that new power supply? So let's bring this window up. Alright. Yeah, server's operating normally, as you can see here. Well, I don't see any new hardware in there. I don't see that the power supply shows it's been replaced, but that doesn't mean anything. I'm not a real big fan of this integrated management module either. Here we go. Power supply 1. Yeah, okay, so it's seeing them both as Emerson power supplies. You can see that right here. Power supply 1, power supply 2, system board. And then, let's see, it shows I removed this power supply, the ACBE, and added that, and then it shows I added the DASD backplane. Well, that was on 330, okay, follow it down. Removed, Emerson, added. I'm just looking for where it shows I added the network card. No, that's not it. Okay, well, it's in there. Windows found it, so we know it's working. So that's, I guess that's a good thing. The beauty of these higher end servers, the Dells, the IBMs, the HPs, whatever brand you prefer, is the fact that you have got, for $200, you have got processing, memory, CPU cycles to spare. And you know, I did my video where I set up a Dell to host up to 15 virtual machines, because I had a client that, you know, had an issue with going from physical machines. They didn't want to invest a lot of money in new physical machines. They had all their old used PCs laying around. They're 7, 8, 9, 10 years old, some of them, and they you know, they didn't want to have to spend $800, $500 to $800 a PC to upgrade them. So we were in the process, as you know, of virtualizing those machines, and so far it's going very well. The response has been very good, and every user I've spoken with has said it has doubled or tripled their speed. They're very happy with the results. So that's what this lab server is for. That's what I've delegated or relegated this IBM is to being my lab server, so I can put operating systems on here and play around with it. So I just want to give you an idea of the power of this server, and I'm going to do a little demo now to show you exactly what it is I'm talking about. Now, all of this ties in together, so let's talk about my Synology NAS for a bit. I want to go over to the Storage Manager section, and you can see that I now have 12, thanks to Sasha Lopez and to my other subscribers. Sasha donated these two 6 terabyte drives to me about a month ago, and then I've added 2 4 terabyte drives to it as well. So now I have a total of 12 terabytes of storage on my Synology NAS. This is my production NAS, and as you can see, I've got a lot of programs running. We'll cover this later, but what I wanted to show you that I did was I went out here and I created a couple of iSCSI LUNs. These are file level LUNs, and then I attached some targets to them, one for my lab and one for production, and each one of these is 500 gig in size. Let me see if I can show you that here. Yeah, so each one is 500 gigabytes in size, and they're dynamically expanding, so they're thin provisioned. But this was one of the other reasons I got the Synology, is because I wanted to be able to use iSCSI to have centralized storage. Now, what I've chosen to do is rather than have multiple machines connecting to each LUN, I don't think that's a good idea. I dedicate a LUN to each unit. So I created 2 LUNs, and then what I did was I created 2 iSCSI targets, one for each LUN. So LUN 1 is the MCS lab. You can see that right here, LUN 1, 500 gig. And I've named that MCS lab, and you can see my MCS lab.local is connected to that. And then for my production server, I created another LUN, LUN 2, and I connected that to the production. You can see that here. And I'm going to do a separate video on that, but I just want you to see I now have LUNs, iSCSI LUNs set up for both my production server, the Dell, and the IBM X3650. So having those iSCSI LUNs gives me the capability of having more storage. So if you come under here under computer management and you go down to disk manager, when it comes up, you'll see now that the iSCSI LUN is connected, and I've given it a drive letter J. Then I also have a SSD drive in there, a 255 gig SSD, which reminds me I am asking for donations to buy a 1 terabyte SSD. So if anybody wants to contribute to the drive fund, I want to get a 1 terabyte SSD drive and put it in here because I'm rapidly running out of storage space. And then here's the 140 gig SAS drive that came with that IBM server. So I don't store any of my virtual machines there. I store either virtual machines here if I need what I call tier 1 storage, which is really fast storage. I store that here on my SSD. And for normal, like servers and non-workstations, that kind of thing, I store my information on my iSCSI LUN on drive J for MCS Lab. So if I come into Hyper-V, let's go to the domain controller lab one. You see I've started repopulating my Windows Lab units. I'm restoring them from a Veeam backup. Again, another handy thing I have. We're building upon building upon building. You remember when we created the Windows Lab, we created all these virtual machines, and we created these domain controllers. And then I either exported them, moved them to a different Hyper-V server, or I backed them up with Veeam. So, I mean, your choice. But this is what the Synology or any NAS will give you, is the ability to do all these things in a lab environment and to see how this really works together. Now, what I wanted to show you on my virtual machines here, on my virtual servers, their hard drive is located on drive J, which is that iSCSI LUN over on my Synology NAS. You know, the servers just basically need to boot up and serve. There isn't a lot of hard drive activity going on these servers. So they boot and they boot off the iSCSI. Same way with this one here, it boots off of the iSCSI LUN. It's drive J. Remember, drive J is the iSCSI, and the drive D is the SSD. Now, for my Windows 10 units, for example, let's go to settings here, and you'll see these hard drives are all on my SSD drive. They're on drive D right there, as you can see. The Windows 7 units, though, are over on, well, the Windows 7 Ultimate 1 is on drive D, but the rest of these Windows 7 units I have put over on the iSCSI drive. Now, what I'm going to do now is I'm going to show you exactly what these servers are designed to do and why I spent $200 on an IBM and a Dell server. Let's have some fun here. We're gonna bring this up after we get the virtual machine started. But right now, our CPU utilization is under 1%. Our memory in use is 5 gig of 48 gig total, and our Ethernet activity is, you know, not a whole bunch of Ethernet activity. That's going to spike. This is going to spike, but especially this, because some of these machines are going to boot off of iSCSI. So what I'm going to do is I'm going to start spinning up virtual machines. So it's just a matter of right-clicking on the VM and telling it to start. And I'm going to go ahead and start all of these Windows 10 units. All of these boot off of the SSD drive. All of these Windows 10 units. So now that we're booting them up, you can see the increase in CPU utilization. And just keep an eye on them as they come up. You'll see what kind of utilization they have over here and the kind of utilization they have over here. Now, all of these Windows 10 units, I believe I've given them I've given them 2 virtual processors. I've given them 2 gig of startup RAM and enabled dynamic memory. They can use up to 4 gig per virtual machine. So they've all started up now, and you'll see my CPU activity start to go down. And we're now using 20 of the 20 gig of the 48 total gig of memory, and not a lot of activity on our Ethernet because we're not booting any of these machines off of iSCSI. In fact, I'm going to go ahead and start this Windows 7 machine. That boots off the SSD drive as well, and you'll see our Ethernet activity stays relatively low. But I want all these virtual machines to boot up and stabilize, so I'm going to let them all boot up. I'm going to give them a few minutes, and then I'll come back after everything is stabilized. So while we're waiting on those virtual machines to stabilize, you can see I brought up the performance or resource monitor on my Synology NAS. Now, you can see the CPU utilization, memory, network, disk, volume utilization, iSCSI, see my throughput. And once you set up your iSCSI, you can even come up here and you can drill down to the LUNs and you can see the actual throughput, the IOPS. That's very handy to have. I get very good I am pleasantly surprised at the speed of iSCSI on these Synology NASs. Very simple to set up. We'll have a whole video on that. We've done one previously, but now that I've figured it out a little bit more, we'll do another video. But this is LUN 1 and then this is LUN 2. LUN 2 doesn't have any activity because I don't have any virtual machines on my production server that currently boot off of there. But we'll keep this on LUN 1, and you can see the IOPS coming through here as the machine runs. Now what I want to do is go ahead and boot up all my other Windows 7 64 Ultimate Lab units, and I want you to pay particular attention to the Ethernet connectivity. It'll disappear as I boot these units up, but I'll bring it right back up. So I'm going to go ahead and start all of these. Except for the last one. And you should see now that we are receiving data at 139 megabits per second, not bytes but bits. And then if we switch over here to the Xmonology or to the Synology NAS, you'll see now that we are definitely booting those machines off of the iSCSI LUN. You can see my IOPS here. You can see my latency. It's quite acceptable. I'm getting really good IOPS on these, and then these machines boot fairly quickly. But you can see the throughput, which tells you they are definitely booting off the iSCSI. I'll go ahead and do the last one here. Go ahead and start it as well, and then we'll switch back over to the Synology NAS, and you can still see we're getting very good throughput. Very little impact on CPU and RAM for iSCSI. Keep in mind, it's basically it's very similar to like directly attaching a hard drive, except you're going through a network controller. Now these two NIC cards are bonded. You can see that I have two network interfaces on this Synology, and I bonded them together. The plan is on the IBM server to bond those together as well, two of them together, and get 2 gigabit of throughput. But for now, I just wanted you to see how it was doing with iSCSI. So you see here everything's pretty much calmed down now. They've done their big spike, which was booting. We're still only using 25% of our available CPU resources, even with, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 virtual machines up and running. We're using 17 gig of the available 48 gig of RAM. And you notice something on the memory. If I come down here to memory, we have set up dynamic memory on all these machines so that they only take the amount of RAM they need. It's a real good way to manage your RAM resources if you have a low amount of RAM. And Microsoft handles the RAM very well. Well, you know, with their own operating system, that's easy to do. I don't know if it supports virtual RAM on Linux machines or not, but we'll do an episode on that one of these days. But I'll give you an example of the kind of speed, because you're probably going, yeah, they're running, but they're very, very slow. Well, let me show you. I'm just going to go into a console, and I'm just going to log in here real quick and show you what a Windows 7 virtual machine looks like. And let's go into Chrome, and let's do some web browsing and that kind of thing. Alright, we'll go to the Chrome Web Store. I'll just bounce around here. Evernote Web Clipper. Let's see, what is that? Okay, that came up fairly quick. How about EarthView? Yeah, that comes up pretty quick. I think I have Office on here, so let's bring up Excel. Let's bring up Word. Let's bring up let's bring up PowerPoint. And let's bring up, yeah, we know they're not activated. That's okay. We don't care. We like living on the edge, don't we? And then Publisher. Okay. And if we come back and look, we see our RAM increasing a bit, but very little impact on the system. Very little impact on the iSCSI. It's just chugging right along, working just fine, right? Now, the other thing I want to do while I got a live captive audience here. Now, these are on my subnet 20. These are on their own VLAN. I was able to get the VLAN configured by watching Willie Howe's video on configuring VLANs with Unify. But I want to come here and I want to go to my I'm coming now on the 5.5 network instead of the .20. So I'm coming on to a different domain in a different subnet, and what I'm looking for is the VLC. And let's see what version I have. We'll load this one. I just want to play a video. We'll play a standard definition video, and then we'll play a high def video, so you can see. I'm just doing the install, nothing like doing it live. But it's just like sitting down at a physical computer. I mean, you know, I can't, you know, it's not any faster or slower. The programs load. Now, The kicker is going to be when we actually go to play video. I want to go over to Unky Joe's Playhouse, and I'll come up to my finished originals here. And actually what I'm going to do is I'm going to come down to an old video. Let's just launch our vlog video, because I can play these without any copyright infringements. Now you're not going to hear the audio, and the video is a little herky-jerky. Yeah, you can see it's kind of pixelated. Not too bad. I mean, it's not really watchable, but I would imagine if I did an RDP session, it would be very watchable. Now, I just want to try something with YouTube as well. So we'll go to our apps here and go to YouTube. I just want to see if it'll even play a YouTube video. Let's see, not trending. Let's just go to Home Lab. Let's go to Rob Willis and see his Home Lab. And as you can see, it's playing. And let's go ahead and bring it up full screen. Let's see if I can do 720p. It looks like I can. So don't let anybody tell you that virtual machines you can't. I'm not even doing RDP, which would be actually a little bit faster than using the console. As you can see, I'm using the console. I've got, 14 other virtual machines running. It's really, look at it grinding on the CPU. Whenever you play a high-def video in a virtual machine, look at that. Now let's see what kind of usage I'm getting on this machine. It's only showing 7% on this VM, but you can see it is grinding those CPUs. And I bet you if I pause this video, the CPU utilization will go down, and it does. So you can tell, even though Hyper-V is telling you that you're only using 5 to 7% of your CPU, and I think I have a dual core. I've given this 2 cores, yeah, 2 virtual processors. But you can see when you play those high-def videos that it really gives the system a run for its money. And it really is kind of a joy to see all these VMs up and running and see the CPU utilization, because it makes you feel like the money you spent on this device was well worth it. So you could do this by building, an i5 or even a Ryzen machine. But by the time you buy all the parts and get the RAM and everything, you're looking at what, $600, $700, $800 to build a machine. I bought this used server again for $200 online. And I've added a NIC card. I've added the little key so I can do the remote desktop or remote settings on it, and boot it up remotely. And you can't get all that stuff in a custom built PC. It's only available in a server, or hell, the add-on card to add KVM capabilities to a standard machine is a couple $100. That gives you the ability to remote power it on and go to the BIOS and that kind of thing. So by the time I bought that card, I could have bought a server. Now granted, this server is going to use more energy than a regular PC would, but electricity is fairly cheap where I live, and I think of it as just another space heater. So, but it's nice to see that CPU utilization being put to use on a server. Now this server does not stay up 24/7. It is my lab server, but it's nice to see it getting a workout after all these years. I mean, this machine is 11 years old, and it's still relevant today. I just love it. All right, so let's have a little conversation. I got this wonderful IBM server behind me here. We've done the network card in. Now we've replaced the power supply that was defective. So one of the complaints I have about these services, now power where I live is fairly inexpensive, but I don't like to be wasteful. And these machines are really, these servers are really powerful. And let's be realistic here. In the United States, and I'm sure over in Europe and overseas, we've used incandescent light bulbs for years. And my father was of the subject of the opinion that more light is better. He hated 60-watt light bulbs because as he got older he couldn't see, so he was putting 100-watt light bulbs in every lamp we had. This was before they even put the little labels on there telling you not to put larger than a 60-watt bulb in there because it could melt. But this was back when the lamp bases were made out of metal. They were safer. You could put a bigger bulb in there. We used to run 100-watt light bulbs in our lamps in the living rooms, in our bedrooms, all the time. And they did two things. They used a lot of electricity, and they heated up the house. So when we all switched over to CFLs and now LEDs, we're using a lot less power, and the lights put out a lot less heat. But let's face it, this server behind me is basically two 100-watt light bulbs when it's running. It's not a whole bunch of energy to be consuming. But if it's going to be consuming that energy, it needs, in my mind, it needs to be doing something. So that's a problem. That's the only problem I have with these servers. Is this one is my lab unit, so it's not on 24 hours a day, 7 days a week. But my Dell unit is on 24 hours a day, 7 days a week, and I have all these processors that are not being utilized, and all this RAM that's not being utilized. And it would be nice if I had a program to run on there that could get utilization out of all this power and then somehow help the community while I'm doing it. Well, have you heard of BOINC? Okay, BOINC is an open source software for volunteer computing. So, if you would like to assist scientists and universities and companies helping them doing computing large projects, then BOINC is for you. It is for me. I like to dedicate and donate my extra computing power to solving some of the mysteries of science and technology and cosmology and that kind of thing. So I downloaded. Now, normally you would put BOINC in a virtual machine. I don't do that. I'm putting BOINC right at the root of my server and giving it access to all the processors and the power it needs. And that's what I've done on this lab unit, is I have actually put BOINC on here. So I'm going to go ahead and minimize. Actually, I'm going to close my Hyper-V Manager. I don't need to have that open right now. But I have put BOINC on here. I loaded it. And then what you do with BOINC is you join a project. And you become a member of a project. And I've chosen a couple. I do cosmology at home, and then I do SETI at home. And then what happens is that they download onto your computer some programs that run in the background and just, basically grind and do some computing while you're not using the computer. Makes sense, right? So that's what I've done. Right now it's suspended because I've limited it by the time of the day. But if I go here to options and then computing preferences, you'll see that I've only compute between 1 a.m. and 8 a.m. And I've limited it to use at most 75% of the CPUs. Now, if you hover over these, you'll see that it tells you exactly what these settings mean. So it helps you to do the settings correctly. I don't have a GPU on here, so I don't worry about those, but it'll tell you how to limit the processor usage, how to limit your network, your disk and memory, and then what your daily schedules are. So if I just wanted to run now, I can just take this check mark off. I'm going to do that here in a minute and show you what it looks like. Then your transfers to your for the data going in and out will be here. Your statistics, how much disk space it's using. So right now, SETI at home is using 28 meg, and Cosmology at home is using almost a gig of hard drive space. And then they go out periodically, and they will transmit their information back to the home computer, the mother computer. But I got to thinking, this is a really good way to kind of burn in servers too. And I'm thinking of approaching some of my customers and going, look, you don't use your servers after 6 p.m. at night, 6 p.m. till 6 in the morning. Maybe let's put some software on here, help find a cure for cancer, or to find some cosmological things, or search for extraterrestrial intelligence, whatever your current motivation is. Put it on there and let it use these CPU cycles that you're paying the power for, but you're not actually using. So I just think this is a really neat idea to put on especially a high-end computer like these servers are when you're not using them. So I'm going to go ahead and let it run. Let's bring up the task manager. Now this program is smart enough to know that it'll limit its resource usage if something else is in use. I hope I said that right. Now you notice I had 15 virtual machines up and running. I'm not going to change that. I'm just going to come up here to options, and I'm going to go ahead and let it rip. I'm going to take the check mark off on the compute only, and then you'll see these things start firing up, and it really starts hitting that processor. Uses a little bit more RAM, but you can see it's now these SETI programs are running. And if you come over here to your processes, you'll see it lists each process and how much CPU it's using, how much memory it's using, etc. So I like to let that run when I'm not using the server, to go ahead and do these computations and to kind of give back to the community. But you'll see, now let's go into it. Let's just, for giggles, we'll minimize this. Let's go into a virtual machine. Sorry, I hit the wrong one. And as you can see, my interface is still fairly zippy. Let's go into a Windows 10 machine here. We'll connect up and log in. Probably not a good indicator here to do this virtual machine, but I'm just going to go ahead and do it anyway. Let's load Excel, let's load PowerPoint, Publisher, and Word. Speed's not bad at all, not at all, considering that it's got about a 90% processor usage, 100% processor usage. You can see it just saturated these processors, and but my virtual machines are still running right along, doing very well, and this is through a console connection, not even through a RDP session. Let's go out to YouTube and see if we can stream a video just for chuckles. You're seeing it live, and you can see the server is getting a pounding. Looky there. What were we just talking about? iSCSI. Let's go to Morton's video. Let's see what Morton has to say. Actually, you won't hear Morton. I'm going to skip the ad. I'm going to make sure it's at least at 720p. See if it can do the video. Let's do it full screen. Let's really put it through its paces here. There he is. There's Morton. iSCSI target setup on Windows Server 2016. Morton needs to watch my upcoming iSCSI video on my Synology NAS. I'm very happy with the speed I get with that Synology NAS, like I showed you earlier in this video. But you can see, even though we got 100% CPU usage, we got 15 virtual machines running, and now we have BOINC running, using those CPUs like crazy. We're still able to stream a high-def video on a virtual machine, and it's not that laggy, all things considered, when you consider what this server is doing. So we're actually using the server now. I love it, huh? Alright, let me stop this video and log out of this virtual machine. I just wanted to give you a little, let me close this. Still not a bad, it's still a snappy interface on the virtual machine. I'm just as surprised if this as you are, but this gives you an idea of the power of these commercial grade servers, and you can see Windows is managing the memory very well, and yeah, BOINC is still running in the background and doing very well as well. I'm going to go ahead and close the Hyper-V manager, and BOINC knows when to stop its computing tasks in the background when the operating system calls for more processing power or more RAM. BOINC just gives it up automatically, And so you can, in theory, even leave it running during the day. Now the proof would be, you know, to have actual people doing actual work on these virtual machines. But, you know, the reason we buy these servers is to utilize them. So as you can see, by adding BOINC to my equation, I am really getting good utilization out of these IBM and in the future Dell server. So yeah, money well spent on that IBM and that Dell server. And as you can see, replacement parts, add-on parts are easily available for both of these servers, both the Dell and the IBM. Which server do I prefer? Well, of course, the Dell. The IBM server is great. It's just as powerful as the Dell. It's got the same features with the exception of a couple of things. One, the Dell server is much quieter than the IBM. I mean, I can hear the hum behind me as we speak from the IBM server. I can never hear the Dell when it's on behind me. That is, unless it's initially booting up. The other thing that irritates me about the IBM is I really don't have any way to monitor the power usage on that server. In the Dell, it's built into the iDRAC controller. On the IBM, there is no way to track the power. You would have to put a power monitoring device on it. But like I said, I like having these servers, if they're going to be up and running, doing some real work. And you know, SETI and cosmology studies, those are the kind of things using BOINC that you can do, and it kind of gives back to the scientific community, and we all, you know, kind of contribute to one another and help each other out. That's what life's all about to me anyway. So, you know, I have all this computing power, let's put it to work, right? So there you go. We hope you found the video entertaining and informative as always. If you liked the video, please smash that like button, give us a thumbs up. Leave your comments down in the comments section. Subscribe, and don't forget to hit the notification bell so that you know when we post new videos. If you're so inclined to donate, we take PayPal and Patreon. Either one is fine with us. We are trying to get some more money, some more donations together to get a 1 terabyte SSD drive to put into this new IBM server. So we got a lot more videos planned with these IBM servers, with Synology, with Xmonology, a lot of stuff coming up. I got so many videos rolling around in my head, it's not even funny. So thanks again for watching. Come back and see us again, and don't forget that we will see you on the other side.